This is the first section of chapter 6 on linear programming, and this section is all about linear programming problems. So we need to go through some terminology first. So the first thing we're going to look at are variables that we use, and these are often things like x, y, z and so on. And the name for these, we call these decision variables. Decision variables. Then we'll have some inequalities, and we'll often write these inequalities ourselves based on some statements that are given in the question. So we may have something like, I don't know, 5x plus 2y has got to be greater than or equal to 10, something like this. And when we have these inequalities, these are what we call constraints. Constraints. Now, when we combine our inequalities and we draw them graphically, that will lead to something that we call a feasible solution and a feasible region. So we're looking at plotting these inequalities graphically, and we'll have some sort of region. Let's say we've got some inequalities like this, one there, one there, and one here. So we'll have this area in the middle here, which we call the feasible region. The feasible region. Now, often in these questions are either about minimizing a cost, so minimizing a cost, or maximizing a profit. So maximizing a profit. So we'll be minimizing or maximizing a cost or profit, which is known as the objective function. So the objective function. So this will be, let's say, something like profit is 2x minus 3y, something like that, and we'd want to maximize that, or some sort of cost. So I'm just making these things up. So let's say 7x plus 3y, and we'll either want to maximize our profit or minimize our cost. And in these questions, once we've minimized our cost or maximized our profit, that's what we call the optimal solution. So once we've done this, we will get the optimal solution. So this first section is all about taking some statements, and from those statements we want to write some inequalities, we want to write some constraints, and also what we want to write down is what the objective function is. So from our statements, we're going to write some constraints, and we're going to write down our objective function. Okay, so let's read through this information. So Mrs. Cook is making cakes to sell for charity. She makes two types of cake, a fruit cake and a chocolate cake. So maybe we'll highlight that. Fruit and chocolate, two types of cake. Amongst other ingredients, each fruit cake, okay, so the ingredients for the fruit cake are 1 egg, 250 grams of flour and 200 grams of sugar. Each chocolate cake, so the chocolate cakes here, requires 2 eggs, 250 grams of flour and 300 grams of sugar. Mrs. Cook has 36 eggs, okay, 7 kilograms of flour and 6 kilograms of sugar. She will sell the fruit cakes for £3.50 and the chocolate cakes for £5. She wishes to maximize the money she makes from these sales. Okay, in other words, she wants to maximize her profit. You may assume she sells all the cakes that she makes. Formulate this as a linear programming problem. So the first thing I need to do is decide what my decision variables are going to be. This problem is all about the number of cakes she needs to make. How many fruit cakes, how many chocolate cakes, given the constraints she has, given the ingredients, how can she maximize the amount of money she's going to make from the sales? So first of all, I'm going to use X to stand for the number of fruit cakes that she sells, and I'm going to use Y for the number of chocolate cakes. So number of chocolate cakes. The next thing I'm going to do is to write down what my constraints are. Now these are going to be inequalities. So go through it sentence by sentence. So amongst other ingredients, each fruit cake, okay, and I'm using X for the number of fruit cakes. So every fruit cake requires 1 egg. So I'm just going to talk about the eggs first. So each fruit cake requires 1 egg, so 1 times X. Each chocolate cake requires 2 eggs. So every chocolate cake needs 2 eggs, so that's 2Y. Now, if I continue down here, I can see that it says that she has 36 eggs. So the number of eggs that I use cannot be any more than 36. I can use less than 36, but no more. So that inequality here, this constraint, represents what we can do with the eggs. Don't have to use all of them, but I can't use any more than 36. So let's go on to the next ingredient, which is the flour. And we'll do this here. So with the flour, a fruit cake needs 250 grams. So I'll do 250 per fruit cake, so 250x. And the chocolate cake is also 250 grams of flour, so plus 250y. Now this is in grams for flour. She's got 7 kilograms of flour, so we can use up to basically 7,000 grams of flour. Now we want to write our inequalities as simply as possible. So if I divide everything by 250, what I will get is X plus Y is less than or equal to 7,000 divided by 750, which is 28. Okay, so there's my second constraint. So it might be worth just putting these in boxes so we don't lose them as we go along. Right, now we'll move on to the next ingredient here, which is the sugar. So for the fruit cakes, each fruit cake requires 200 grams of sugar, so 200 grams for each fruit cake, and the chocolate cake requires 300 grams of sugar, so 300 grams of sugar for each chocolate cake. Now how much sugar have I got? 6 kilograms, so I can use up to 6,000 grams of sugar. Again, I'm going to simplify this. I can divide everything by 100, and that will give me 2x plus 3y is less than or equal to 60. So that's my third constraint here, so let's just highlight there. So we've now gone through all of the ingredients, and now we're going to form what we call the objective function. Now the objective function will either be to maximize a profit or minimize a cost. She will sell fruit cakes £3.50 and chocolate cakes for £5. She wants to maximize the money she makes from the sales. So we want to maximize this, the profit. Okay, so P stands for profit in this case. And how do I make my profit? Well, she's going to sell $3.50 for each fruit cake. So I'll put 3.50 per fruit cake plus £5. I could just put 5 or 5.00 for each chocolate cake. Now with any linear programming question, we always need to consider non-negativity. In other words, we need to specify whether any of the variables that we've defined here can be negative. And in all of the questions, they're not going to be. They're all going to be positive, but we need to state that. So we need to say that x needs to be greater than or equal to 0. Y needs to be greater than or equal to 0. We can combine this and say that x and y, like this, need to be greater than or equal to 0. So our final solution is going to be a list of all these inequalities. So we'll do it down here. So we've got x plus 2y is less than or equal to 36. We've got x plus y is less than or equal to 28. We've got 2x plus 3y is less than or equal to 60. And our objective function is to maximize our profit, and that will p equals, and I can just write this as 3.5x plus 5y. And then I must include my non-negativity of my variables here. So this would be our final answer to this question here. Okay, so this is example number 2. What we're going to do, we're going to read through it, and as we read through it, we're going to write down the constraints and objective function as we go through. So starting with the first line, company buys 2 types of diary to send to its customers, a desktop diary and a pocket diary. So the first thing I'm going to do is define my variables, and I'm going to say x is going to stand for a desktop diary. You could use D if you wanted to. And y is going to stand for a pocket diary. And if you wanted, you could use p if you wanted to, but I prefer to use x and y. Okay, so that's the first line done. They will need to place a minimum order of 200 desktops, diaries. So the number of desktop diaries has to be 200 or more. And the number of pocket diaries, y, needs to be at least 80 or more. Okay, so that's now the second line of sentence done, turned into a constraint here. They will need at least twice as many pocket diaries as desktop diaries. Now this is where you need to be careful, because often students will make a mistake on this part of the question. So I'm going to show you something that's going to help you to get the inequality right. So this is going to be my working to help. So the first thing I'm going to do is to write down the letters that I've got, the variables that I've got for the pocket diaries and the desktop diaries, and I'll write them in the same order as they're written in the question. So pocket diaries is y, desktop diaries is x. And I know that this number here needs to be at least twice as big as this number. Okay, so let's just put some numbers in. So let's say that this number here was 100, yeah, because it's probably easier to put in the x. Then this number would need to be 200 or more, at least twice as many. So the first thing is that gives us the relationship between x and y. So x times by 2 is going to give me y. So I'm going to start with that. And the first thing I'm going to write down is that x times by 2 equals y. Now that will be if it was twice as many, but it needs to be more. This y needs to be greater than x. It can be equal to x, but greater than x. Now what we're going to do is we will look at the inequality backwards. Y needs to be greater than or equal to 2 times x. And here we have our inequality. So we've actually thought about the inequality going this way. So drawing a table like this can help you avoid the mistake of getting this inequality wrong. Okay, next thing, they will need a total of at least 400 diaries. So the total number of diaries is going to be x plus y, and it needs to be at least 400, so 400 or more. We move on to the next line. Each desktop diary costs £6 and a pocket diary costs £3. Okay, they want to minimize their costs. So we'll have C for cost, and it's about minimizing this. And their costs are £6 for a desktop diary. So that's 6x plus £3 for a pocket diary. So that would be our objective function. So let's now write down all the information that we've got. So we've got x greater than or equal to 200, y greater than or equal to 80, 2x less than or equal to y, x plus y greater than or equal to 400, and we said that we wanted to minimize our cost, which is 6x plus 3y. Now normally at this point we'd put our non-negativity constraints and say that x and y both need to be greater than 0, but it's already here. Yeah, if x needs to be greater than 200, we know it's going to be greater than 0. If y is going to be greater than 80, we know it's going to be greater than 0. So we don't need to do our non-negativity constraints here. So this would be my final solution for this question here. So just like before, we're going to go through each question or go through each sentence and we'll write down the information as we go along. So the first thing it says here, company produces 2 types of syrup, syrup A and syrup B. So I'm going to use X to stand for syrup A and Y to stand for syrup B. Okay, so we'll just tick that off. We've just done that. The syrups are made of a blend of sugar, fruit and juice. Syrup A contains 30% sugar, 50% fruit and 20% juice. Now, anytime you get a question like this, where you have percentages, then we'll express our inequalities using decimals. So just like the question that we had for the cakes and we did like eggs, sugar, flour, we're going to do the same thing here. So we'll be looking at sugar first. Okay, so we'll look at each of the ingredients. So let's maybe highlight these. So syrup A, 30% sugar, syrup B, 20% sugar. Okay, now there's some other information about sugar down here, but we actually need to read further down to see what's going on. It says the company will blend both of the sugars. So in other words, the sugars are going to be mixed together. And in that blend of syrup, and 60,000 litres of this syrup, the total of that blend, the amount of sugar needs to be below 25%. So this is how we're going to write it. So syrup A, 30% sugar. So we'll do 0.3x, 30% of x. Then syrup B, so we're adding them together here because it's a blend. These two syrups are going to be put together. 20% sugar is in syrup B, so 0.2y. And that amount of sugar needs to be below 25% in the blend. So less than 0.25 of the blend, which is what you get when you put them together. So 0.25 times x plus y. So we want to simplify this if we can. Now, if we expand the brackets on the right hand side, we'll have 0.25x plus 0.25y. If we take away 0.25x from both sides, then we will have 0.05x, and then if we take away 0.2y from both sides, we'll have 0.05y. Then we can multiply everything by 20, and we'll just have, simplifies to x is less than y, so times by 20. Okay, so we'll highlight that. Now, the inequalities that we write for the fruit and the juice are going to be done in a similar way. So let's go on to the fruit. Syrup A is 50%. Syrup B is 35%. So maybe I should highlight these here. Then in the blend, then the amount of fruit needs to be at least 40%. So it needs to be 40% or more. So in the blend, it needs to be at least 40% or more in the blended syrup. So we'll expand the brackets and simplify like before. So 0.5x plus 0.35y is greater than or equal to 0.4x plus 0.4y. If we take away 0.4x from both sides, we'll end up with 0.1x is greater than or equal to, because we're going to take away 0.35y from both sides, and that will leave us with 0.05y. Then if we were to multiply everything by 10, or even 20 actually, so that we don't get any decimals, this will become 1 and this will become 2. So this simplifies to 2x is greater than or equal to y. So we'll just highlight that. Then the last ingredient is going to be the juice, 20% juice, 45% juice. So inequalities again, so I'll just write down juice here. So 20% of syrup A plus 45% of syrup B. And what does it say down here? No more than 35% juice. So we can go up to 35% juice in the blend, but no more than that. So that needs to be less than 35% when we put the two syrups together. We'll expand the brackets and simplify like before. So 0.2x plus 0.45y is less than or equal to 0.35x plus 0.35y. Now we want to avoid the negative, so we won't take away 0.35x from both sides. We will take away 0.35y from both sides. So that will give us 0.1y is less than or equal to, and then we'll take away 0.2x from both sides, and that will leave us with 0.15x. We want to simplify this. So maybe what we'll do is we'll times both sides by 10. 100. So we will then get 10y is less than or equal to 15x. And I can see that I can simplify that by dividing both sides by 5. So I'll get 2y is less than or equal to 15x. And we'll probably want to write it the other way around. Sorry, not 15x. We were dividing it by 5, so it's 3x. So we might flip it around and write it as 3x is greater than or equal to 2y. So we'll just highlight that inequality. So we've done all the ingredients. Okay, we've got some other constraints as well here. So the maximum daily amount, or there's a maximum daily amount of 40,000 litres of syrup A. So syrup A cannot be any more than 40,000 litres, and syrup B cannot be any more than 45,000 litres. And in this bit here where it says that they place an order for 60,000 litres of syrup, that's the blended syrup, so x plus y, it says they place an order for 60,000, they cannot have any less than 60,000. Okay, so rather than equal to 60,000, it cannot be any less than 60,000. So we'll just highlight those, and now we can move on to the objective function, and we'll find the objective function here. Each litre of syrup costs 50 pence, each litre of syrup costs 40 pence, and what do we need to do? They want to minimise their costs. So let's write down the costs. What are their costs? Well, it's 50 pence for syrup A, so let's do it in pounds, so 0.5x, and it's 40 pence for syrup B. Now what we could do is we could multiply those by 10 and say their costs are 5x plus 4y, because we really want to avoid decimals where we can and work with whole numbers. Now if we do write it in this form, we need to realise here that the 5 stands for 50 pence, not £5. So you may prefer to use this because you know that this is in pounds. This isn't in pounds here. This is in 10 pences, so you may actually prefer to work with the previous one. So actually we'll leave it like this, because then we know that we're dealing with pounds. Right, so now I can write down all my inequalities for my final answer. My constraints: x is less than y, 2x is greater than or equal to y, 3x is greater than or equal to 2y, x needs to be less than or equal to 40,000, y needs to be less than or equal to 45,000. Quite a few constraints here. X plus y needs to be greater than or equal to 60,000. Also, we need to look at non-negativity. So x and y both need to be greater than or equal to 0. We can't have negative amounts of syrup. And then lastly, we want to minimize this objective function, which is our cost, which would be 0.5x plus 0.4y. So we'll just highlight that. This would form then our answer for this question. All our inequalities here and our objective function. So you should now be able to do exercise 6A on pages 143 to 145.